Good day, everyone. Allow me to introduce the proponents of this research. First of all, yours truly, Brian Wong, along with Mario Laureta and Olwin Barcoma, and along with our advisor, Engineer Angelino A. Pimentel, PhD, in progress. Now, without further delays, let's get right into it. We'll start things off with the premise of this research. To be more specific, why do we need this research? We all know that soldering can be a very time-consuming process. It can take a large chunk of your time. So, if we automate the process of soldering, to be more specific, make it hands-off, more time will be spent on doing more productive stuff in your research. Additionally, with the presence of toxic fumes, this takes a toll on one's health if exposed to for extended periods of time. And next, with commercial products with the same purpose being out of budget for many people like aspiring engineers or maybe even hobbyists, we wanted to build a less expensive alternative which is on par with the proper soldering technique. Which now brings us to the objectives of the study. So our general objective is to fabricate a cost-efficient an automated soldering machine that solders circuits properly and accurately. Our specific objectives over here, which is to make a machine that is cost-effective, to devise a machine that is time-efficient, to create the system of operation to be more consistent and accurate, to design a safer and more hazard-free system and working environment, and finally, the machine has to meet the standard of proper soldering technique. So here is the machine in action. So as you can see, here is the x-axis and there's the y-axis. So we have here the servo motor being tested. As you can see, after the motors have been tested, the soldering head has now been assembled. And in this clip, we are also testing the servo motor's movement. As you can see, here's the servo, providing the up and down motion of the soldering iron. And finally, here is the machine in action. Now, first off, for our first objective, we can see that we have achieved it with a cost efficiency of 600%. Our prototype cost around 22,370 PHP, and here are the available machines that can be found online. Next is the time efficient side of the objective, and here are the differences. As you can see, at some points, the prototype is faster, at some points it's slower. After analyzing this data in the Minitab t-test statistical analysis, we can accept the null hypothesis if it is greater than the alpha value of 0.05. And the third, we have the system of operation to be more consistent and accurate. At some points, the prototype performed better. At some points, the participants were the better solderers. And similarly, we also use the t-test statistical analysis in Minitab. We can say that the automated machine were consistent and accurate. Our next objective is to design a safer and more hazard-free system. And that's what the fans are for, and this emergency stop button. And finally, to design a machine that meets the standards of the proper soldering technique. Cost-efficient side, we can say that the prototype is at a far lesser cost, at around 600% lower, and the prototype is able to match the time of the test subjects, thus proving that it is time efficient. So third, it is able to be consistent in its accuracy as stated before with the data. The electric fans are able to vacuum out the soldering fumes. And finally, as we discussed earlier, it is able to meet the standards of the proper soldering technique. Thank you for watching, and I hope you have a great day.